Thank you. Our next speaker is Jeff Weber.
Thank you, and welcome to Super Science Saturday. Oh, wait. Thank you.
Let's do the arrow, Jim.
Okay, hi there. I'll be talking about some recent weather events, particularly in the Northeast United States. The picture here is Hurricane Sandy as she's rolling up the Carolina coast, and the picture on the right is the Mid-Atlantic Derecho as it rolled over 5,500 joules of energy of Cape. What's been going on in the Northeast? As we can see, there's been hurricanes for a long time. You know, this is nothing new. Almost every decade, there seems to be a fairly significant event. There's a couple of clusters. This was a big year, same year as Hurricane Hazel. You know, 60, 85, a little bit of a space here. 91, we had Bob. Now, Sandy came late. Sandy was here in October, so Sandy's way down here. You know, we don't expect a whole lot of big things to be happening this time of the year, but we did, and so that's kind of part of the reason why Sandy was so novel in the way that it acted and behaved, because it was a very late season storm. Now, these are factors that we're adding to Sandy. Sandy made landfall at high tide during a full moon. It just doesn't get any worse for sea level and for surge. It was a late season storm. The late season storm means that it was interacting with very cold air while yet still having a nice warm ocean to draw energy from. Fast moving. Now this is a global perspective of Hurricane Sandy. On a global scale, it doesn't look that impressive, but keep in mind that that's about 1,400 kilometers of fetch as it's coming on in. And so as it's interacting there with the cold front, we have a couple more of these frames where I can highlight some of these interactions. Again, it doesn't look that spectacular looking at it this way, but it was an incredibly large storm in its size and scope. You can look at this forever, I guess. Moving right along. Okay, so another really novel part about Sandy is that it was one of the first very large tropical systems to go above the jet stream. Now we're seeing here, this is the jet stream coming down, and here's Hurricane Sandy north of the jet. A tropical system north of the jet. That's just crazy. It just doesn't happen. And so as we go on to the next animation, we're also going to see how this reinforces and how that surge came in at the very end. These green areas are the jet stream, and you'll notice it gets a kick in the pants as it comes on in. Watch that flow around the ridge, and there's a little jet going from the east to west. We're zooming in here, and we'll see that little jet wrap around that high-pressure ridge off of Canada right there, kicking it into the coast. That's what kind of accelerated to about 30 miles an hour as it made landfall. That increased the surge. These aren't advancing, I think, because of the animation, so I'm just going to take the liberty of doing that myself. Okay, so we're back to sea level rise. Now, if New York City was about 30 feet higher than it currently is, Hurricane Sandy wouldn't have had much of an impact. The winds were, 90, 100-mile-an-hour winds. The rain was not apocalyptic. It was the surge. It was the storm surge. It's the sea level. Now, if we look at the Northeast, over 1950, 2009, up to present, we're seeing tidal gauges and showing how sea level is rising much more dramatically in the northeast part of the United States than it is in the southern part of the east coast of the United States. So the Northeast is preferred, and that's primarily due to wind flow and salinity and pressure. This is an Atlantic City sea level rise going from 1900 to present. Does anybody see a trend? So it is happening. This is real. This is very real. And so it's one of those exacerbating factors for hurricanes. Where is all this water coming from? This is Arctic sea ice extent. The lighter shades here are the 1980s. We're kind of stepping down by decades. And again, does anybody see a trend? We're losing 400 kilometers, 400 square kilometers of sea ice from 1980 to now. Here's another visualization of the Arctic sea ice extent provided by the National Snow and Ice Data Center. Again, the trend is very obvious. It's very much real, and it's very much there. And so we're getting all this melt from the ice caps, and that's what's adding to sea level rise. There's also one other factor for adding to sea level rise, and that is thermal expansion. About 50% of sea level rise is due to the influx from glaciers and melting ice sheets, whereas the other half is due to thermal expansion of the water. So it's not all just the runoff. We can't just look at the volume of the sea ice and say, oh, that's it. It's half of it's thermal expansion. Back onto derecho. Derechos are big, strong, flat line winds, and they tend to kind of go around heat ridges. So there's kind of a play on having a big mega heat ridge and having these ring of fire storms that come around. And so we're going to be taking a look at this mid-Atlantic derecho. And I want you to take a look at this as it comes across Iowa, going across northern Indiana, picking up the moisture there from Lake Superior. And when you look at this, tell me if it doesn't look like Hurricane Sandy playing backwards. Okay? I don't know why Mother Nature was so angry with New Jersey this year, but she whacked them a few times. I mean, that eye coming off of there is right at Atlantic City. That's the exact same landfall for Hurricane Sandy. So a very rough year for them, and I don't know, maybe it's the Jersey Shore or something like the show. I think we're still going to be stuck on this, yeah. Okay, so now we're looking at wind reports. This is from the Derecho. And if we're looking at some of these extreme wind gusts, 91 miles an hour, 81, 59, these are like hurricane force winds on a straight line wind event. And so there's actually some, in Maryland by Germantown, they're showing 70, but we also have some ground reports of 100 mile an hour winds there as well. So this was an incredible event. Look at the cohesion of that radar signal as it rolls off from Iowa all the way out to the East Coast. This is like a 24 to 30 hour event, went through 7 states, maintained its water source in front, and was just incredibly powerful. I talk about heat too because heat can do a lot of things other than age storms and so on. They can buckle railroads, they can cause heaving in roads. This is from Baltimore. They also had heavings in roads in New York during this big heat rage. And so heat is also a factor that can play havoc with our infrastructure. Conclusions. The Northeast United States isn't an area for enhanced sea level rise. It's going to rise more, almost 4 times more than other areas in the globe. So it's a real concern. All storms will likely be more intense. This is due to the water aspect. Frequency of tropical systems are not going to be increased, and it's water, 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 man. It's all about the water.
Any questions?
Any quick questions for Jeff?
Jeff, you said the Northeast U.S. is at risk for high sea level rises more than any place in the globe. Does that include places like Bangladesh?
Yes. And so, while Bangladesh and the islands in the East Pacific might be more significantly impacted by sea level rise, the actual magnitude of sea level rise is going to be more extreme in the Northeast United States than anywhere else on the planet, based on current modeling. And that's based on a couple of factors. One is the fact that as the ice sheets melt, their gravitational pull weakens and all that water goes away from the poles and comes towards the equator. And also the way that the winds are going to be changing in a climate change environment. A lot of the winds will be pushing up against the east coast of the United States and the density and the salinity. And so there's a couple of reports and modeling efforts that have gone into place, and they show that the Northeast United States will possibly see as much as 9 feet, 2+ meters of sea level rise by 2100, which is about 4 times the global average. Sea level is not homogeneous. It is not the same across the globe. The Marianas Trench is like 20 meters below the rest of it because it's a valley. So it kind of follows the bathymetry of the ocean.